Hello and welcome to another CS200 mini lecture. In this mini lecture, we will continue our discussion around collections, which is chapter 16 in your Xi book. What we will do is go through some additional examples. So it would probably benefit you most to go through the first lecture on chapter 16.1 through 16.6 before viewing this. However, let's get started. Let's begin by looking at a collection. So we import javautil.asterisk. This imports the entire library. And we also do IO. So this is just a shortcut so we don't have to import individual packages here. So what we do is we declare a class called listExample. And we're going to create an instance of a list. And notice we declare it as an array list. And it's going to be of type string. The next is to add three values. So we add them in the order of Google, Apple, and Microsoft. And then we have this sort method, which is built in as part of the collection. And what we can do is we can actually do collections.sort. So this is the actual class, and sort is the method, and then company list is what we're going to sort. So that's what our array list. What this does is it sorts it in ascending order. So we have right now Google, Apple, Microsoft, and what we want to do is we want to sort it in the order of Apple, Google, Microsoft. So then we print them out. So compile this, and then we run it. And lo and behold, it puts it in the correct order. The sort gives us the ability to do it in ascending order. So if we want to do it in a different order, we might have to do the following. So again, this is our list, just like we saw in the previous example. This one's called listExample2. We create the same array list. We populate it with the same elements. But here, we create a comparator. And what the comparator does is it's an object that allows us to go in a different order. So we have comparator, it's of type string. The name of it's called COM. And what this does is this takes two strings. So it's going to take two of the values, and then it's going to compare them. And we're going to sort the list based on this comparator. Now last time we just did collection sort, and we didn't have this value here. So what this allows us to do is to sort in some kind of order that may not be in ascending order. And then we print it out. So let's try using this comparator and see how it works. Okay, so this was from the first run where we got an ascending order, and this is actually in the second run, and you can see it's in reverse order. So by creating a comparator, we have more control over how we sort our particular rows. Continuing our work with lists, let's take a look at another demo. In this one, what we're doing is we're creating a list. We're going to call it L1, and it's going to be an array list of integers. Remember, with add, we have two ways of referring. We have index and element, or if we just put element, it would add it to the beginning. So in this case, it may not make sense to put it at 0 since it's empty anyway, but just to demonstrate, we put it at element 0, and the value is 1 that we're going to put into that array list. Now we're going to add 2 at position 1, and then we're going to print it out. So we'll see how it looks. Next, we're going to create a second list, and then we're going to add 1, 2, and 3 to it. And what that's going to do, of course, with a list is it adds it to the end. So then we add list L2 from the index of 1. So what we're doing is we're adding the list at position 1. So it's going to insert the entire list. Remember, we have 1 and 2, and we're going to insert 1, 2, 3 in the middle of that. Then we're going to remove an element that's located at position 1, and then we're going to print that out. And then we'll also print out the element at index 3. And next, we're going to use the replace to set a value at index 0, and that value will be 5, and then we'll print our list. So this has a lot of output. So I'll leave this window open while we run it. And then when we look at our output, we get the following. In the beginning, we just added it to position 0 and 1, and we got 1, 2. So that is what we expect. And then remember, we added this other list in the middle, and that's 1, 2, and 3, which we see was added to the middle of our list. So we can add a list to another list. Then we remove the element from index 1. So remember, this is now 0, 1, 2, 3, 4. And we removed this guy to make it look like this. Then we print out the element at index 3. So this is 0, 1, 2, 3. So it's going to print out this 2, which it does. And then we're going to replace the beginning element with a 5 and then print it out. So before we had a 1, and now we have a 5. So let's take a look at an example showing how we create a list. So in this case, we have a list called AL, or A1. And so we have a list called A1. And we're going to add programming, then we're going to add fun, and then we're going to add to position 1 is. And then we're going to print it out. Let's compile this, and we're going to run it. And we get it just as we expect. So this gives us control over our list in terms of what is positioned where using that index with the add. Now remember, the set method, it allows us to change a value that exists in our list. So let's take a look. So we're going to add CS120, CS200, and then in the middle we're going to add math150. And then we're going to print out the initial array list just to see what it looks like before. And then we're going to do the set, which is going to change the middle value to CS160. And then we'll show the updated version of our list. So we'll go ahead and run this. And what happens is our initial list has math150, which we changed to CS160. The remove works very similarly. So we start with the same values, and then we remove the value at position 1, which is going to be the math150, and then we remove CS120, which is the beginning one, and we should just end up with CS200 at the end. So again, we start with adding the values. We print out the initial array. We remove the first element, which is the middle element in our case. And then we remove this one by position, and this one by name. So continuing our examples on lists, we have one that we iterate through them. Remember the example we saw in the text. We start out with the 3 values, we add them in the same order. Then we print them out, so we're getting each value. And then here's another way to do it using that iterator. So this is just a fancier way to do what we need to do. And notice how we declare that iterator that replaces all of this plus the declaration of a string. So it's a much more efficient way to do this, although we're not using the list iterator here. It's just an enhanced for loop. Let's go ahead and run it and see if we get the same results with each of the 2. So we should see the same list twice. And yes, we do. So there's two different ways to do our looping to print out the values in our array. And notice we're not just printing out the entire array list because we don't have brackets. We're printing out the values. We're just doing it in order. So now let's take a look at some set examples. In this one, the set is one in which we can perform standard set operations on. And this might be useful when you're trying to deduplicate rows, for example. So we start with a hash set called A and B. So A is going to contain these values, and B is going to contain these values. And notice they're not in order, and you've got duplicates in here. So if we want to find the union, what we do is we do union add all B. So what that does is that provides a union of the two sets. We can also find the intersection. So we have add all, and we have intersection retain all. And what this does is this shows the values that are in common, and then we can find the symmetric difference between the two sets. So let's do this. Let's compile it and run it. Going back to our original sets, A and B, we can see that when we do the union, it provides the values. And look, it provides them in the order. The intersection is just the ones that are in common. So what we have is 0, 1, 3, and 4. And then the difference is those that are not in the intersection. So those would be the remaining values. Now let's go through an example showing hash maps. So we create a hash map that's going to have string as the key and integer as the value. So we have CS 10, map 30, stat 20. So we can print out the size. Remember, the size returns the number of elements. We can also print out the entire hash map. And then we can check if a key is present. Remember the key value. So key is the string. We can check if a key is present, and if it's present, we'll print out the value associated with it. So we look for CS, which exists, and then if it exists, we print out the value associated with it. And how we print out the value with it is by doing this get. So let's go ahead and compile this and run it. And so we get the size of the map is 3, just as we would expect. We have the values that are put out inside of our hash map. Notice the curly braces. And then the value for the key CS, which exists, is 10, just like we would expect. One nice thing is the ability to print out frequencies of all the elements. Say we've got a large collection. And remember, with a hash map, it's not necessarily ordered. So because it's not ordered, we may have a problem finding a particular value. So checking the frequency helps us a great deal. We create a hash map, which in this case is 2 integers. So here's our declaration. Our hash map will be called hmap. We will traverse through the array by doing a for loop, which we just go through the length. And then we declare integer. Notice the capital I equals get the value at a particular position, and we return that as C. So if it's the first occurrence of that element, then this is how we would check that. We would say we put that array value in position 1. Otherwise, we put it after wherever that element exists in our list. So if we have 10 elements and it shows up at position 10, we would put it after 10. Then we want to print the result, and we will do the frequency. So we can do this by doing a for map entry m colon hmap entry set. So that's going to loop from the value m through this whole set. It's kind of a fancy way of just looping through all the values. So we can do the frequency, and this would be the get value. And then here's our input. Let me just add some values to make it more interesting. And then let's run it. So what we get as output is the hash map as well as the frequency of each term or each value in that hash map. And you can see it's not particularly ordered well, but to our chagrin, this is kind of the nature of having a hash map. There's another one the textbook did not talk about, and that's a tree map. So what a tree map does is a tree map allows us to keep things in an order. So we'll see if the output differs from what we see in the previous hash map example. So I've updated the value of the array to input, and we'll see if the output is the same. Lo and behold, unlike what we got with the hash map, the tree map puts the values in order. So although we print out the actual mapping here, when we print out the values, we can see that we get them in an order that we would like to see. The primary difference between hash map and tree map is that hash is not ordered, but a tree map has a specific order. Now let's take a look at DEX, because I think DEX is something that may be interesting and useful to many of you, especially if you're going to model stacks. So we declare a DEC here, we just give it the name DEC, and we can add them either to the front or the back. So here we add one to the tail, then the head, then we do add last to the tail, and then we push, and that would add to the first. Then we add the last, which is offer, and then we add it to the first, which is another way of adding to the head, and then we will print out our list. And then there's also a way we can remove the first and the last, and then we'll print out the list again after removing those. So we'll run this and see our results. Just as we expect, we add to the head. You can see the values here, and then we add to the tail. And remember, we added them 1, 2, 3, 4, 5, 6. And then after we move the first one and the last one, we get the middle 4 as our DEC. Let's take a look at another example using the array DEC. So here we declare our DEC. This time we call it DQ. It's going to be strings. And what we do is we add A, B, C to the front, then D to the end, and then we add E. So what's going to be our order? Is it going to be A, B, C, D, E? It's not. Let me give you a minute to think about that. But this will show you how we can add values at either the front or the back. We'll go ahead and run this. So notice that when we did the add first, it didn't put it at the end, it put it at the beginning. So that's why we don't have it in alphabetical order. Let's take a look at another example. In this one, we're going to add the values just as we would expect, and then we're going to pop and pull first, pull last. We're going to see how this affects our DEC. So we're going to compile it, and then run it. So we begin with C, A, B, D, E. We pop C, and remember it removes it from the DEC. We pull A, which also removes it. We pull first, so that's going to pull B off. And then we're going to pull last, which is just going to leave D remaining. So here we have an example using an iteration of elements. We'll have the same starting DEC, and then we're going to use a normal iterator and then a descending iterator. So there's a way to use an iterator that we're going to declare to go in either ascending order, which is normal, or descending order, which is one we have to specify. So let's run this. So if we use a normal iterator, we get BACD, and then if we use a descending one, we get it in the reverse order. Now for our last DEC example, we have here is, we call it DE_QUE, and then we add 5 values, 10 through 50, and then we output the values. We use the clear method to show that it actually removes everything. And then we add first, and then what we do is we add last, and then we take a look at the queue. Let's go ahead and compile and run this. So here is our starting DEC. After we clear it, before the insert, you can see that clear statement did this. We insert in the beginning, and then after the add list, we insert at the end, and this is what we end up with, just as we would expect. Collections are an easy item to test because we can just put values in, and we can test out many of the collection methods that are supplied. We've taken a look at a couple of lists. We've taken a look at a set, hash map, tree map, and also DECs. So if you have any further questions, feel free to explore them. There's many resources online, and I'd be happy to answer any questions you have.